A very good morning from Goregaon MPS Municipal Secondary School East, BMC Education Department. So today I am going to present you the topic of lenses from Science 1. So let's start with our topic. Okay. So first of all, today we will see what do you mean by the real image and the virtual image. Now what happens that when we are studying about the lenses, now while studying the lenses, we are getting the images. Okay, we are keeping the object in front of the lens and then we are getting the image in the screen, on the screen or on the particular lens. So what type of that image will be? Will it be a real image or it will be a virtual image? So to understand that, first we should know the meaning of the real image and the virtual image. Now, first of all, a real image is formed due to the actual intersection of the reflected ray. Now, whenever there will be the intersection of the reflected ray, so that will be the point where the where the image will form. Okay, so whenever there is an intersection of the reflected ray, then only a real image can be formed. Then for the virtual image, we can say that a virtual image is formed when the reflected rays it meet if they are produced backwards. That means reflected ray, those whatever the reflect, first of all, as you know that the incident ray is fall on the lenses. Now after falling on the lenses, what will happen? Reflected ray will appear from it. So for the virtual image, those reflected rays they will meet, but where? Beyond the lens. Okay, that will be produced backward of the lenses. So the virtual image is formed, they are formed or they are produced backwards, whereas the real image is formed before the lenses. Okay, then comes the real image can be obtained on the screen. Okay, real image they can be obtained on the screen, whereas the virtual image cannot be obtained on the screen. Then a real image is inverted with respect to the object. It will not be straight, it will be inverted. Suppose a candle is placed. Okay, now if the candle is placed, in that case what will happen? The image, the real image, whatever we will get, that we will get inverted form. Okay, that means if the object is erect, if the object is straight, that is the flame is upwards, then in the real image we will get the flame downwards. That will be your inverted image. Then for the virtual image, a virtual image is erect, that it will be formed as it is straight candle. If object is a straight candle, then the image will also be a straight candle. Okay, so with respect to the object, only the difference in the size will appear in the virtual image. Then the image of a distance object formed by concave mirror. Then the image of a for virtual image, the image of an object formed by plane mirror or by a convex mirror. So these are the examples. So now in this picture you can see, let's see what is a real and the virtual image. Now here you can see the example that now here in the first, that is a real image is always inverted. Now you can see the flame of a candle. Okay, so flame of a candle is inverted in the image. Okay, now whereas in the virtual image it is as it is straight. Okay, and you can see the image is formed on the lens. Okay, then convex lenses form a real image, whereas the virtual image is formed by the concave lenses. Then real images are formed on the screen, whereas the virtual image they appear to be on the lens or on the mirror itself. You can see here this example. Now here in the picture format you can understand that real images they are formed on the screen. Okay, whereas the virtual images they are formed on the mirrors or on the lenses. Okay, now see, you can see this, the correlation between the real and the virtual image. Now, whatever points we have studied, okay, about this, from this difference, that a real image is formed due to the actual intersection of the reflected ray. Now, here you can see with two intersections. Now, two reflected ray, they intersect at a point. Okay, now, here a real image, here the image is formed and it is in the inverted form, whereas the virtual image, this virtual image you can see it is erect as it is like an object, only the size differ. Okay, so this is a virtual image. Okay, so let's recapitulate the rules which we have studied in the last lecture about the images formed by the convex lenses. So first of all, the first rule is when the incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Now here you can see from rule 1 picture that incident ray, okay, whatever the object is placed, from that whatever incident ray they are appearing, and after and those incident ray, if it is parallel to the principal axis, then what will happen, whatever the reflected ray will be there, that will pass from the principal focus. Okay, this is your first rule for any object. If incident ray is parallel to the principal axis, then the refracted ray will pass through the principal focus only, not from other point. Okay, then rule 2. Rule 2 is that okay, if the incident ray, it passes through the principal focus, you can see from F1 the incident ray is passing. Now in this case, okay, whenever the incident ray passes from the principal focus, then the refracted ray is parallel to the principal axis. Now this refracted ray, it will be parallel to the principal axis. You can see refracted ray which is parallel to the principal axis. So always remember, if suppose for any object, if incident ray is passing through the principal focus, then it will surely and definitely the refracted ray will be parallel to the principal axis. Then the third rule is that when the incident ray, it passes through the optical center of the lens, then it passes without changing its direction. It will pass as it is. Okay, from the point O, you can see point O is the optical center. So if the incident ray passes from this optical center of the lens, then it will pass without changing its direction. Whereas in the other rule, in rule number 1 and 2, the direction of the incident ray, it changes. But for the rule 3rd, here, if any ray, it passes from O, then it will not change its direction. It will pass as it is. So with these 3 rules, few of the images which are formed by the convex lenses for different positions of the object, we will apply these 3 rules in that. Okay, so let's study it. Now these are the rules. These are not rules. These are the images formed by the convex lenses from these 3 rules which we have studied. Okay, now we will see one by one. Okay, now the images formed by the convex lenses. Now here, first one is the position of the object. Okay, now as you can see, first of all, in this picture, whatever picture is shown here, so you can see that AB is the object. Okay, then focus points are given. Then after that, O is given, that is the optical center. Then after the lenses, focus points are also given. Okay, then after that, image is formed, that is A dash and B dash. Okay, so here one by one we will see. Now if suppose the position of the object is at infinite distance. Okay, now if the position of an object is at infinite distance, the position of the image that will be formed will be on the first focus, that is F1 point. Okay, and the size of the image will be a point image, and nature of the image will be real and inverted. Now how come this happens? So we will see from this picture. Now here you can see first case, that is the object at infinity. So now here in this case, object is at infinity distance. So that means the object may be it can be anywhere. So we will not show the object here because it is at infinite distance, which we can't show in a paper. So in this case, we will only show the incident rays which are passing from that particular object. Now here you can see whatever the incident rays are there shown with an arrow which is going towards the lenses. Those are all the incident rays. Now, if the incident ray is parallel to the principal axis, so I hope you have understood which rule can be applied here. So whatever 3 rules we have seen, the first rule, that is if the incident ray is parallel to the principal axis. Now here in this case, you can see that the incident ray which is falling towards the which is falling on the lens, so that incident ray is parallel to the principal axis. Now the first rule, if the incident ray is parallel to the principal axis, the refracted ray pass through the principal focus. So only that rule is applied here. Okay. So whatever all the incident rays coming from the object, okay, and all those rays they coagulate at a point, okay, and there we get a point image, and the nature of the image is real and inverted. Okay, so the image which is formed is at the focus, at the focus point. Now here you can see incident rays are all passing, and after that the first, with the help from the first rule, whenever the incident ray is parallel to the principal axis, the reflected ray will pass through the principal focus. So that only first rule is applied here. With the help of first rule, we have drawn this figure, and if you tally the points which is given here, that at infinite position, if the object is there, then the position of the image will be on the first focus, that is f1, and the size of the image will be a point image, okay, and the nature of the image will be real and inverted. So you can see this picture. Then afterward, the second point, beyond twice f1. Okay, so here if the object is beyond twice f1, then the position of the image will be between the f2 and twice f2, and the size of the image will be smaller, and the nature of the image will be real and inverted. So let's see this, how it happens. Now if the object is beyond twice f, okay, then what will happen? Now AB is the object name. Okay, so here you can see the object AB, okay, it is beyond twice f. So incident ray will come out from those objects. Now here you can see two incident ray passing from the lenses. Now always remember, while drawing the ray diagram, we have to consider two rays at least, okay, because only after the intersection, if only whenever the intersection of the refracted ray happens, then only we will get the image. If intersection between the refracted ray will not happen, then we will not get the image. So intersection is essential, and for that intersection we need at least two rays which is coming out from the object. Okay, now so two incident rays are coming out from the object, and two refracted ray we are getting. Now here in this case, the first incident ray, it is parallel to the principal axis. Okay, you can see from point A, two rays are coming out. So first is the incident ray, okay, which is parallel to the principal axis. So according to our first rule, if the incident ray is parallel to the principal axis, then what from the refracted ray will pass from? It will pass from the principal focus. Now here you can see from the first incident ray, the refracted ray it is passing from the principal focus. Then comes the second ray, second incident ray, which is coming out from point A. So here you can see that this incident ray, it is going, it is passing through the optical center of the lens. Now according to the third rule, okay, according to the third rule, when the incident ray it passes through the optical center of the lens, then it passes without changing its direction. So that's why it is going straight away. Okay, now after passing from the optical center, okay, beyond the lens, now wherever it is intersecting with the first refracted ray, okay, there the image will be formed. So here you can see with the intersection of the refracted rays, one image is formed, that is A dash and B dash, and it is an inverted image. Okay, and the size of the image is also smaller than that of the size of the object. As you can see here, AB is little bit bigger than that of A dash and B dash. So our second case is, if the object is beyond twice f, then what will happen? The image which is obtained will be between the f and twice f. Okay. So here in this case, the whatever the image it will be formed, it will be nature of the image will be real and inverted, and the size of the image will be smaller. Then comes the third case, that is at twice f1. Okay, so whenever your image is at object is at twice f, okay, what will happen? Now you can see here at twice f the object is there AB. Okay, now here in this case it is written that whenever the object is at twice f, then the position will be position of the image will be at twice f. Okay, twice f2 position. If the f1 is the uh, po- principal focus before lens, and f2 will be the position after lens. So in that case, the position of the image will be twice f2, and size of the image will be same size, and the nature of the image will be real and inverted. So here we will study the case 3, that here if the object is at twice f position. Now AB is the object. Now uh, it is again releasing two incident rays. So first incident ray, it is parallel to the principal axis. Now whenever incident ray is parallel to the principal axis, so our first rule says that then whenever the incident ray is parallel to the principal axis, the refracted ray will pass through the principal focus. Now here you can see from the incident ray first, the refracted rays passing from the principal focus, that is here it is given f2. Okay, then after that the second ray which is coming from the object AB, it will pass from the optical center. So according to our third rule, whenever the incident ray passes through the optical center of the lens, then it passes without changing its direction, so it is going straight away. So the two refracted ray, they intersect at a point. Okay, and that point of intersection forms an image, and this image is a dash and b dash, as you can see here. So the image which is formed is at the position of twice f2. You can see here at twice f2 position the image is formed. And why this image is formed at twice f2 position? Because of the intersection of the refracted ray. Okay, so here we have applied rule number 1 and rule number 3. Okay, then here in this case the nature of the image is real and inverted, and the size of the object is size of the image is same as it is of AB, object AB. So here a dash and b dash is the image which is formed, which is of same size as that of the object AB. Okay, then comes the fourth case, that is if the object is between the f1 and twice f1, then the position of the image will be beyond twice f1, and then the size of the image will be larger one, and the nature of the image will be real and inverted. So let's see this case 4, that if the object is between the f1 and twice f1. Now here you can see object AB is between the twice twice f1 and f1 here. Okay, now in this case, again from the object, we will consider two incident ray. One incident ray will be parallel to the principal axis. So rule number 1 will be applied here, that the refracted ray, then it will pass from the principal focus. Okay, then the next ray, it is passing from the optical center. So the refracted ray will be passed without changing its direction, as it is, it will go through, and then the point of intersection of both the refracted rays, at that point we will get the image a dash and b dash, and that image is real and inverted. Okay, you can see it is inverted. So here in this case, rule number 1 and rule number 3 is applied here. Okay, and the image which is formed is larger. As you can see, the object AB is smaller than that of the image A dash and B dash. So here you can see the image which is formed is larger, it is real, and it is inverted. Okay, it is not straight as it is that of the object, it is inverted. Okay, so here we are getting the position of the image will be beyond twice f2. Okay, the position of the image will be beyond the twice f2 here. So this is the case if the object is between the f and twice f. Then comes if the object is at the focus, that is twice f1 position. The position of the image will be at infinity. Then the size of the image will be very large, and the nature of the image will be real and inverted. So we will study this case. So this case 5th tells us that if the object is at f1 position, Then you can see object AB is there on F1 position here, and two incident rays will be released by, we will consider from this object which is released. Now here, first incident ray. Okay, the first incident ray is parallel to the principal axis. So according to the rule number 1, if incident ray is parallel to the principal axis, then the refracted ray will pass from the principal focus. So here you can see the refracted rays pass from the principal focus. Then the second incident ray, it is passing from the optical center. So according to the rule number 3, here whenever the incident ray is passing through the optical center, it will pass without changing its direction. So you can see the refracted ray, both the refracted rays, they are moving further, but here on paper it is not possible to show us the intersection. So that intersection will happen somewhere to a far distance. So that's why we will write the position of the image at infinite distance. So at infinity you have to write here, because here intersection on the paper is not possible. It will move on, it will intersect at far away distance. So here it is not possible as to show on the paper, so we will write the position of the image as infinite. Okay, and as the image is forming to a far distance, so it will be a bigger image. Okay, now always remember, as the object is coming closer to the lens, the size of the image will increase. Okay, here you can see here from right from the first case. Okay, not, don't consider first case, consider from the second case. So you will understand that as the object is coming nearer and nearer, the image, the size of the image, it is going on increasing. Okay, so here in this case, we will apply for case 5th rule number 1 and rule number 3rd. Okay, then comes the last case, that is if the position of the object is between the F1 and O. So here position of the image will be formed on the same side of the lens as the object. Then the size of the image will be very large and the nature of the image will be virtual and erect. So here in this case you can see. Now you can see that the object the object is between the F1 and optical center, between the optical center and the principal focus. AB object is present between the F1 and O. Now in this case what will happen? Again, two incident ray we will consider. So first incident ray is parallel to the principal axis. So according to the first rule, what will happen? The refracted ray will pass from the principal focus, from the F2. It is shown. Then the second incident ray, it will, if it is passing from the optical center, so according to the rule 3rd, then the refracted ray will pass from the O, and it will be and it will pass without changing the direction. You can see here. So then what happens here? Now here, after the lens, it is not possible to get the image. So what we will do, we will extend those refracted rays. Okay. So here you can see with the dotted line, it is refracted rays are extended, and that dotted line show at the point A dash and B dash we are getting the image. So now in this case, the image which is formed is very large, it is virtual, and it is erect. Erect means it is straight. Okay, you can see the object AB and the image A dash B dash, both are, means the object is smaller and image A dash B dash is larger, and both and A dash B dash is erect. It is not inverted as we have seen in the other cases. So here in this case it is erect and virtual. Now you can also specify one thing, that uh, for the convex lenses, if you are getting the uh, image, okay, on the same side of the object, then it is a virtual image. And if you are getting the image on the other side of the object, then it is a real image. Okay, so these are all the 6 cases which are shown in your textbook, and with the help of these diagrams, I think that will be easier for you to understand how these point images, then how larger images are formed, all, and how real and how inverted. And in all these cases, the three rules which we have studied, okay, these three rules, all these three rules are applied. So if you know these three rules, then that will be easier for you to draw any of the ray diagram. Okay, now with the help of picture format, we will see, suppose in place of an object, we have taken a bulb. Okay, and that is a distant object, or you can say it is a the object is at infinity, suppose. Then what happens? Whatever the incident ray is coming out, okay, that incident ray, you can see here, after coming out, then the refracted ray, they intersect at the point F. Okay, and we are getting a very small image which you can see here. Then if the object is at 2F, okay, then what happened? We are getting the real and inverted image, same size as that of the object, as you can see here, at twice F. Now whatever cases we have seen here, on this is the ray diagram, and this is in the form of picture, so that will be easier for you to understand. So first of all, the distant object means when the object is at infinity. That is the first case. Okay. So here you can see at point F, we are getting the point image. Okay. It's a small size bulb, but it is real and inverted. Then the object at 2F. Okay. You can see whenever the object is at 2F, that is the third case. Okay. Then what will we will get here? Real inverted, same size as that of the object at 2F. So here you can see in the third case also, that object at 2F, A and B, two incident rays will be released, and we are getting an image which is of same size as that of object. So here also you can see this is the third case, object at 2F. Okay. Then comes the object between the twice F and F. So this will be the fourth case, where we are getting the image beyond twice F. Okay. And it is little bit bigger in size, it is little bit larger in size, and it is real and inverted also. Okay. So you can see with the help of this picture, it will be easier for you to understand the fourth case, object in between the F and 2F. So here you can see two incident rays, they will fall over the lens, and after that refracted ray will intersect, and we will get the image which is bigger. Then comes the object at F. Okay, now this will be your whenever the object is at F, that is at focus F1, you can see that is case number 5th. At focus twice F1. So here position of the image will be at infinite distance, size of the image will be very large, and nature of the image will be real and inverted. So here also you can see with the help of these ray diagram how this is happening. So here in the picture format you can understand that whenever the object is at F1 position, so at the F position, so in that case we are getting the image at an infinite distance. Okay, so that's why, as it is at an infinite distance, so it is not possible for us to show on the paper. So, and if it will be at an infinite distance, so naturally the image which will be formed will be very large, and it will be real and inverted. Then comes the object between the F and the lens. F and the lens means that is the object between the F and optical center. So here you can see the sixth case. Okay, so here in this case you can see that the image is formed on the same side of the lens as that of the object, and it is very large as compared to that of the object. So image which is formed is larger than that of the object, and it is virtual, and it is erect. Okay, it is straight as that of the object. So these are the cases. Okay, this is also there in your textbook in page number 83. These cases are given, and on the basis of those cases, these are the ray diagrams. And in all these ray diagrams, three rules which is given by the images formed by the convex lenses. Only those three rules are applied. So we will recapitulate those three rules once again, that one can use the following three rules to draw ray diagrams of the image obtained by the convex lenses. So when the incident ray is parallel to the principal axis, the refracted ray passes through the principal focus. Okay, first rule. Then second rule, when the incident ray passes through the principal focus, the refracted ray is parallel to the principal axis. Then the third one will be the when the incident ray passes through the optical center of the lens, then it passes without changing its direction. Okay, so here light rays parallel to the principal axis falling on a convex lens come together, so that is get focused at a point on the principal axis. So this type of lenses, they are also known as the converging lenses. That means it coagulates all the rays at a point, so that's why it is known as the converging lens. Then if the light rays, it is parallel to the principal axis and falling on a concave lens. Now, if it is falling on a concave lens, then it will go away from one another, or it will diverge after refraction. And so this type of lens is also called as the divergent lens. Now here for converging lens, we are using convex lenses. And for divergent lens, we are using concave lenses. So understand the difference, that here in the convex lens, what happens? The refracted ray, it will coagulate at a point. It will converge at a point. So that's why they are known as a converging lens. But whereas in concave lenses, okay, their divergence of the rays takes place, and that's why it is known as the divergent lens. Okay, then let's study about the images formed by the concave lenses. Okay, now in this case, what happens? Here you can see in the middle that convex lens is placed. Here also the same case, object is placed, and from that object a few of the incident ray will come out and it will get refracted. Okay, and we will observe the image which is formed. Okay, so here in this case we will see few of the cases, that if the position of the object is at infinite distance, okay, then the position of the image formed will be on the first focus, and the size of the image will be small, or it is a point image, and the nature of the image will be virtual and erect. Now for the convex lenses, mostly the virtual and erect image will be formed, whereas for the convex lenses we have seen real and inverted images are formed. So here, rule first, we will go from the rule first here, that for rules to draw the ray diagram of images formed by the concave lenses. Now here you can see that if suppose the object is placed at infinity, so in that case, the incident ray, okay, here you can see the incident ray is falling on the concave lenses, then what will happen? It will get refracted or it will get diverged. Okay, then what will happen? Here this will now it will get diverged, and the image which is formed, that will be formed on the first focus, or you can say f1 position where it is seen. Okay, then the second rule, that whenever the incident ray it is passing through the concave lenses, then you can see here the refracted ray, it is parallel to the principal axis. So this will be a second rule. So you can see that refracted ray is parallel to the principal axis here. Okay, now whenever the object is placed at infinity, so here in this case what will happen? Now, if the object is placed at an infinite distance, so naturally we are not able to show the object on the paper because it is present or it is placed at an infinite distance. So we will consider only the incident rays. So here you can see with help of arrows, incident rays are shown. So incident ray, it is passing, okay, from the lens, and then what will happen? The position of the image where it will be formed, it will be formed on the first focus, that is f1 position, as you can see. The second incident ray which is going which is passing from below principal axis, you can see that is also, as it passes from the lens, then what will happen? that refracted ray, it will extend and it will touch to the f1 position. So in that case we are getting the image at f1 position, and this on the first focus f1 we are getting the image, and that will be a point image because it is formed on the f1 position here, and the image which is formed will be the virtual image and it will be the erect image. Okay, then point image can also be called as highly diminished, means highly small. Okay, then comes a concave lens, okay, which diverges all the rays falling on it. So here you can see a on the same side of the object we are getting the image here. Okay, so here you can see that the incident ray, two incident ray, one for both of them are falling on the lenses. One will be diverged and second will be passed from the optical center. Then what will happen? We will get an image a dash b dash here you can see, and that will be little bit small in size as that of the object. So here when the object is placed anywhere between the optical center and the infinity, so the position of the image form will be between the optical center and the focus f1. Okay, here you can see between the f1 and optical center we are getting the image, and the size of image is small as that compared with the object. So here in this case the nature of the image will be virtual and erect. It will be straight as it is like that of the object. Okay, only the size will be smaller. Okay, so then comes the sign convention. Now here for the sign convention we will see. Now here first one is for the convex lens and second one is for the concave lenses. Now here, whenever the lens is placed in between, and you know that from the center point, center O is the optical center, then F is the principal focus, then that line which is passing from the F and O, that is known as the principal axis. So here in this case, whenever the object is placed in front of the lens, so the distance of the object from that particular lens will be considered as U. Okay, then V is the distance of the image. Okay, you can see the distance. V will be the distance of the image from the lens. Then F is the focal length. Okay, now focal length is what? Okay, focal length is the distance between the optical center and the principal focus of the lens. It is known as the focal length. Then comes H1. H1 is the height of the object which you can see in the picture, and H2 is the height of the image. Okay. Then comes focal length of a convex lens is positive and the focal length of the concave lens will be negative. Now these things it will be helpful for you for solving the problems. Okay. Further we will see few of the formulas also, so so these things you should keep in mind. U is the distance of the object from the lens. V is the distance of the image from the lens. F is the focal length. H1 is the height of the object and H2 is the height of the image. Okay, then the focal length of the convex lens, it is positive, and the focal length of the concave lenses will be negative. Okay, so these things you should know. So let's in short we will recap the things. Now these rules, these are very important. If for the images which are formed by the convex lens, how it is formed. So rule first is that whenever the incident ray is parallel to the principal axis, then what will happen? The refracted ray, it will pass through the principal focus. Then the second rule, whenever the incident ray passes through the principal focus, the refracted ray will be parallel to the principal axis. Then third rule. Third is when the incident ray passes through the optical center of the lens, then it passes without changing its direction. Then according to that, we have drawn few of the ray diagrams. Here you can see that as the object is coming closer and closer to the lens, the size of the image is going on increasing. Then the image which is formed, it is formed by the intersection point of the refracted rays. You can see here in these diagrams that whenever um, the two refracted rays they are intersecting, in that point only we are getting the image. Okay, then for the convex lenses we are mostly getting the real and inverted image. Okay, so few of the cases we have seen. Then after that, uh, how the images is formed by the convex lenses. So here one bulb is taken. So with the help of bulb, we have shown how it is formed in inverted form, real form, and how will be the size of the image will be formed. So with the help of these cases which is given. So this is the ray diagram and this is in the form of diagram. Then we have seen what are converging lenses and what are diverging lenses. Converging means they coagulate the rays. That means what happens when the light rays it is parallel to the principal axis falling on a convex lens. So they come together and get focused at a point. So on the principal axis. So that is known as the converging lenses. And it happens on the convex lens only, not in the concave lenses. Whereas the divergent lens are whenever the light rays parallel to the principal axis, it is falling on a concave lens. It go away from one another, that is it diverge after refraction. So this type of lens is known as the divergent lenses. Okay, where the refracted ray it diverges. Okay, and it happens only in concave lenses, not in convex lenses. Then we have seen how the images are formed by the concave lenses. So whenever the position of the object is at infinite distance, the position of the image will be at first focus and the size of the image will be a point image and it will be virtual at erect. You can see here. Okay, a point image is formed. It is virtual and erect, and here in this case in position of the image will be at first focus point. Then if the object is placed anywhere between the optical center and infinite distance, then in that case between optical center and focus f1 the image will be formed and the size of the image will be small and the nature of image will be virtual and erect, as you can see here. Okay, so with the help applying these things we have drawn the ray diagrams here. Then sign convention, u is the distance of the object, v is the distance of the image, f is the focal length, h1 is the height of the object and h2 will be the height of the image. Okay, because in the convex lenses inverted image are formed. Okay, after the lenses, beyond the lenses. So here in this case you can see here h2 will be the height of the image. Then focal length of the convex lens is always positive and focal length of the concave lens is always negative. Okay, so let's solve this exercise. Now tell me if what will be the nature of the image formed by the convex lenses. Okay, if the object is placed at an infinite distance. I'm talking about the convex lenses. Okay, so just if anybody know, tell the answer. What will be the nature of the image? Will it be virtual or and erect, or it will be real and inverted? What we will get from the convex lenses? What will be the nature of the image formed in the convex lens if the object is placed at an infinite distance? Now here in this case you can see now for the convex lenses. Okay, now you can see the first case when the object is placed at an infinite distance. So here all the incident ray they coagulate at a point. Okay, and there we are getting a point image which is real and inverted. You can see here in the first picture also you are getting this picture of the bulb away in a very small size, a point image we are getting, and which is a real and inverted image. Okay, next one is what will be the nature of the image formed in convex lens if the object is placed at a focus f1. Can anyone answer? Okay, here also in this case, same. It is asked that whenever the object is placed at focus f1. So if the object is placed as focus f1, then what we will get? Object at f. Here the case 5. Here we are getting an image at an infinite distance, and the image will be very large and it will be real and inverted image. Okay. So here you can see the fourth one, object at f, where no image is shown here because it is at infinite distance. Okay, and here in this case we are not able to show the picture on the paper because the image is formed at an infinite distance. So the nature of the image will be real and inverted. Then what will be the nature of the image in a concave lens if the object is placed at infinite distance? Concave lens. Okay. Now for the concave lens, we have seen. Yes, Anjali, unmute yourself. Yes, Anjali, unmute yourself and answer. Anjali. Okay. So if the object is placed at an infinite distance in a concave lens, then what we will get? We will get that the position of the image will be between the optical center and focus. And the size of the image will be small and it will be virtual and erect. So here, okay. Whenever the object is placed at an infinite distance, the position of the image will be on the first focus and it will be a point image. I will show you. Okay, so here in this case, you can see that a point image is formed and it is virtual and erect. First case, that is whenever the object is placed at an infinite distance. In that case, we are not showing the object because it is placed at an infinite distance. So we are only considering the incident rays. So whenever it falls, so what will happen? The position of the image will be formed on the first focus. Okay, then and that will be the point image, a very small image, a point image, and it will be virtual and it will be erect. Okay.
तो टीचर
Yes.
टीचर आप हमें एक बार नेक्स्ट लेक्चर में मतलब बताएंगे कि ये जो F1 है F2 ये सब जो लिखा हुआ है उसका डिस्टेंस कैसे मेजर करते हैं मतलब
Okay. Okay.
बिकॉज मैम जब बनाते हैं ना तो समझता नहीं कि किसको F1 डाले किसको F2 डाले तो फिर इसलिए जो इमेज है ना वो भी ठीक से बनता नहीं है इसलिए
Okay. अब देखो यहाँ पे इस इमेज में ओके वॉट एवर यू कैन सी इन दिस इमेज ऑप्टिकल सेंटर O है फिर उसके बाद F1 है फिर ट्वाइस F1 है नाउ इन दिस केस O F1 and twice F1 now all the points are taken at the same distance okay so between the O and twice F1 it is placed F1 understanding Anjali who asked this
यस
question Anjali
यस मैम
So F1 is placed between the optical center and twice F1. So that means the distance between twice F1 and F1 and between the F1 and O is same. Same case for the F2 and twice F2. All these things are placed at an equal distance. Okay. आपको ऐसा
ओके
दिखेगा नहीं कि कम ज्यादा डिस्टेंस है ऐसा दिस इज नॉट इट इज नॉट देयर दैट द डिस्टेंस बिटवीन द ऑप्टिकल सेंटर एंड F1 is larger than F1 and twice F1 so we are considered they are at a same distance from O to F1 the distance will be same as that between the F1 and twice F1 understood
ओके मैम मैम हमें मतलब सेम मेजर लेना है ना जब हम लोग ये ड्रॉ
हाँ हाँ
करेंगे
yes yes
ओके मैम
as you can see यहाँ पे भी आप देख सकते हो the diagram may be okay you can see all the distances they are placed at an equal distance okay
एक्चुअली मैम मैं ये ड्राइंग बना रही थी तो मेरा जो रेज है ना वो मतलब पास नहीं हो रहा था जैसे यहाँ पर जो फोर्थ केस में वो कट हो रहा है तो मेरा वो वहां पर नहीं कट हो रहा था
कहाँ पे कौन सा फर्स्ट इंसिडेंट रे या सेकंड इंसिडेंट रे फोर्थ केस में
फोर्थ
ये
केस में सेकंड इंसिडेंट रहे ना वो वहां पर नहीं कट हो रहा था मतलब जो
ऑप्टिकल
टू एफ
सेंटर से
व्हाट मैम
ऑप्टिकल सेंटर से क्या जा पास होने के
हाँ
बाद?
मैम, यस मैम,
अच्छा,
यस।
यहाँ भी ड्रॉ करके देखो ऑब्जेक्ट को बिटवीन द ट्वाइस F2 और F1 के ट्वाइस F1 और F1 के बीच में ठीक से रखो। ठीक है, ऑब्जेक्ट का डिस्टेंस भी मैटर करता है। अगर डिस्टेंस आपका थोड़ा कम ज्यादा हो गया होगा तभी भी वो रेस इंटरसेक्ट नहीं करते अच्छे से। ठीक है, तो ऑब्जेक्ट का जो ऑब्जेक्ट का जो साइज है, ओके, जो हाइट है ऑब्जेक्ट का, वो ठीक से लो और फिर उसको पास ऑन करके देखो, हो
ओके
जाएगा
मैम,
इंटरसेक्ट।
ओके, थैंक यू मैम।
Okay. Okay, so I hope you have understood the topic. So in the next lecture, we will see the further part of this lesson. And I thank you all the teachers and my dear students and BMC Education Department. So have a nice day, everyone. Thank you.